this presentation. I know it's quite interesting having, we've got 3 different sessions running all at the same time, haven't we? It forces people to choose. So thanks to you for coming to listen to this one. And thanks Min for the introduction and persuading me to come through. I'll see if I can get this clicker to work. There we go. So yeah, Min did a good job of introducing me. I think I like to put this slide in. I went on, this is on my honeymoon. We went to Uzbekistan to look at round earth buildings. So that's the level of commitment I think some people need to put in to natural building materials. So I'll just give you a little bit of a background on me. I did a PhD finished in 2008, and essentially I bummed around the world looking at old round earth buildings, which is not a bad way to spend 3 years, really. I'd thoroughly recommend it if anyone wants to do that. This is a Knights Templar castle in Spain that I did a lot of work on, just trying to work out and figure out what was going on, what it was made of, because I was new to round earth. I went through an undergraduate engineering degree, and I didn't really come across earth building and things like that. You don't tend to in current university lectures at the moment. So I found out it was made from round earth, and then we looked at. You can see that building is reasonably cracked, and there's some damage to it. Is that a problem? If it is a problem, how do you solve it? That sort of thing. I believe I know a lot more now than I did when I started the PhD, and I think the industry probably does as well, about exactly what's going on. My specific research, there we go, I went almost as far down as you can go. Basically, we used scanning electron microscopes. We looked at the behaviour of these bridges of water between different soil particles, and how the number and the strength of them can explain the strength and the stiffness and the moisture buffering capacity of earth buildings. And I think that was useful from a fundamental science level, trying to then take that up to an engineering design level and a codes level, I think is a step that we're still working with at the moment. I then became a bit of a structural engineer, did some round earth buildings in the UK. This is a wedding venue, and one advantage of doing wedding venues is they've always got a really good photographer on hand to take beautiful photographs of the buildings. So there are many beautiful photographs of this round earth building that we did in Gloucester in Britain. Again. As Min said, it's not just round earth. I do feel quite a big connection to round earth and a passion for it, but I do feel that it's a construction material, and like a lot of the things we're talking about here, it's using the right thing, the right material in the right place, doing the right things. And as Min alluded to, I was involved in the ModCell. The Eurocell project is part of the ModCell company who make prefabricated straw bale panels, and again it's about gaining code compliance and making sure that you are able to run through and do the things that the code require. And so this is a 30-minute fire test on a straw bale panel. You can see 45 minutes we were doing fine, 51 minutes we got a bit of fire through the panel. So, but the test has been done, it's required, and we can hold up that certificate and say this is what we do. So I think it's interesting to be able to take that experience and potentially put it in with other natural building materials to see how the process can be gone through to gain full certification for natural materials. And now, what I'm doing now, I'm a structural engineer in Warkworth. In New Zealand, which is lovely. I must admit to not specifically choosing Warkworth. Turns out it's a great place to live. I did a geotechnical investigation. This is the plot next to the house I then bought. So that's the view from my window as well now. So this is where I live. I quite like New Zealand. It's very nice. And just to finish, I was asked to go to Nepal as part of the New Zealand Aid team in September, October and November last year to teach about earthquake resistant construction, and that was a fantastic experience. I learned an awful lot about unreinforced masonry design and strengthening of buildings. And I do feel a lot of that can be applied to the natural building materials. And that's new stuff that's come out of New Zealand universities following the Christchurch earthquake. So there's a lot of understanding about the behaviour of unreinforced, low strength, let's say buildings, and how they behave and how they can be analysed more effectively. So that one, in fact, was mud, mortar and fire bricks, and there isn't much information about mud, mortar and fire bricks, so we got some, so that was useful. Anyway, enough prattling on about me. This is what I'm going to talk about. This presentation, it's really, it's in my work looking at historic buildings. I've come across a lot of innovation, and I think my feeling is I see a lot of people saying, oh, this is brilliant, let's do this, what about this? A lot of it has been looked at, tried, failed, worked, not worked, thought about, done, but not necessarily understood, and I feel we're now definitely in a situation where we can sort of take a step back and say, right, what was being done, what's happened, how does it work, can we put a bit of science behind it, and then understand and take it forward. So it's going to be a bit of a snapshot, and it's not going to be very technical, but hopefully I'll generate some debate and discussion for the rest of the conference. So let's start at the very beginning. Jericho, I think we talked about this a bit last night. As soon as you get developed agriculture, you find earth buildings. Before you get developed agriculture, you don't really find much happening. There's not, the earliest settlements with mud brick buildings or mud buildings seem to be from around about 9,000 years ago. And so what you do is you look at those and you find they've got straw in, which is great. Is the straw there because that was a building material at the time? This is pre-pottery, so this is before people invented firing clays. So this is properly unbaked earth bricks, and my argument would be, as soon as you start doing that, people start to innovate and go, oh, this doesn't work quite as well, can we put something else in the mix, do something else, do things, and so you find straw in the mix in these buildings. And I think one thing to point out is this apparently is a food storage area, not a house. So it was stored, so we went from being nomadic and moving around completely into settled agriculture. The first buildings were for the storage of the grain rather than for the houses, according to these archaeologists. So I found that quite interesting. I'll move on. Next one. Does anyone recognise that text?
Hammurabi?
Sorry?
Hammurabi?
Genesis, from the Bible. So that's the Tower of Babel story, essentially, out of page 2 of the Bible, shall we say. The story may relate to is this building built by Nebuchadnezzar. And what he's saying on this tablet that was discovered reasonably recently, but related to a building that was built around about 2000 BC, is I'm building the best building. I'm building the biggest, the best building in the world. What am I using for it? Bitumen and baked bricks. So we've got innovation in earth building. We've got our earth building. We've got our unfired bricks. In order to build the best building 2,000 years ago, what are you doing? You're putting in bitumen, which was abundant in the Middle East around that time. Probably still quite abundant there now. And you're potentially baking the bricks as well. And I just feel that I think a lot of people read the Bible story but don't really relate it to construction, really. So I think it should be a lot more construction in there. Go again. I think moving forward a little bit, this is an Egyptian mud brick stamped with Ramesses II. It's in the British Library, but I think there are lots and lots of them. And what we're seeing there is definite industrialisation of the process. It's a manufacturing process. You're producing a brick to a standard size, a standard form. It's getting stamped and it's going out. It's getting built. So there's definite innovation there in the construction technique. And I presume that happened a long time before 1200 BC. But always we're seeing innovation and we're seeing people people taking what there is and then using it. It's not traditional building. This is cutting edge technology for 1200 BC. And then jumping forward a bit more, but around the world a bit, this is the Hakatulus in Fujian in eastern China, which you should try and go to. They're amazing buildings. They're a World Heritage Site now, which adds to the complexity of their maintenance and upkeep, as happens with a lot of World Heritage Sites. But the main thing I took away from visiting these places is those buildings are, obviously, you don't use anything else, you must use paddy field water to make the round earth. And I'm not exactly sure why, but we'll come to potential reasons further down the line. But someone's looked at that and someone's gone, oh, it seems to work better when we use the paddy field water against using our standard river water. Why is that? What's it got in it? What's extra? Can we take some of that logic, explain what's going on, and then move it forward from now? Okay, and I'm just going to put these things out there because I'm sure lots of us here have read all the books and seen all the things, and a lot of the books say, yes, earth buildings have bone, or they have blood, or they have milk into the mix. I've never personally seen blood and milk in historic structures, and that may be because we're not able to find them through the chemical analysis methods. I have found chicken bones. This is a 14th century Spanish building which we looked at doing some repairs on, and there's chicken bones in the mix, tiny chicken bones in the mix. I don't know whether that's a result of dead chickens or whether they were deliberately added and you need a bit more work on that. But potentially someone thought, right, there it is, there you go. But if anyone's got definite proof for me of blood and milk in earth building mixes, I'd love to add it to these slides. Okay, and then I'm going to talk about lime and cement. I think that what we're doing is we're adding stuff to the thing to make the thing better, right? And it's really a case of what happened and what process was gone through. This started with the Greeks and the Romans with natural hydraulic lime, which is your limestone containing clay. That worked better than just clay when you bake it. So you can see the thought process that went on there. We now understand the process. I presume the Greeks understood what to do, but not necessarily the chemical formulas and the equations behind what's going on. The Romans came along and they found they had this amazing soil, which was like a natural pozzolan, so that's Vesuvius in the background. So if you add that, if you burn that works very well. If you can make artificial hydraulic lime by adding extra clay or extra pozzolans to the mix. And as we know, the Romans did very well out of that and produced some really amazing structures. And this is probably the best one. And there's a lot of engineering innovation in there, but we're moving away from earth building. That's essentially what we're looking at. We're looking to build something. Now, you could argue we've taken so much of the earth out of that. That's definitely a concrete. But you can see it's a material science question rather than just a natural or a traditional building method. This is cutting edge technology, essentially. And I'm not a lime expert, so I'm not going to talk very much more about that. I'm sure there's a lot more people in this room who know a lot more about lime chemistry than I do. But this is one building I like, which is another building I investigated in Spain. It's got a plaque on the door that says this building was built in 967. It's looking pretty good for 1,000 and a bit years old. Really. If you look, it's round earth technique, definitely, but if you look at the actual material matrix, it's very lime rich, it's got round river gravels into it, and that's a graveyard inside the building, so it's acting as a retaining wall with 200 or 300 years of graves in there. It's very eerie to walk around, but if you find yourself in southern Spain, I would definitely go and have a look at that building because it really is amazing. Okay, now I'm just going to talk a little bit about building strengthening, and really that's from a earthquake point of view, I think, in the first instance. But potentially there's other reasons, there's wind and the snow and everything like that. There's additional loads which are placed on the building which it doesn't ordinarily see, but it's got to it's got to withstand. And I think, if you all look up, there is steel strengthening across the top of this building, which I presume is a post-earthquake retrofit, in order to make this masonry building, I think, into a slightly stronger steel structure across the top. So yeah, we're still innovating and we're still learning how to do things. So this is another building in Spain, a horizontal ring beam in the body of the wall. Again, it's very difficult to find these unless the building is damaged, and you need to find a building at just the right level of damage to show you what's there without it being just a big pile of soil, essentially. So there may well be other examples of this that we haven't quite found yet. There's an earthquake in Lisbon in 1790, and I presume there were other earlier earthquakes around the Mediterranean, and so there was an understanding of seismic retrofit and seismic design by the Muslim builders of these castles in southern Spain. Jumping around the world, this is in Jaquin in northern Nepal, and there's a lot of horizontal timber members put relatively randomly into the round earth walls there. I think that's probably an understanding issue that buildings with timber in looked to perform better than buildings without timber in. Brilliant, let's put some timber in. But that's about as far as it goes. And obviously we're now able to understand and look at forces and look at stresses and things like that within buildings, and so maybe use less timber or place it more effectively. But the theory and the understanding and the innovation is there. It's not just playing round earth there. And again, we find the same sort of thing in Morocco. So, different part of the world, built around about 200 years apart. But I've got timber beams on the corners there as well, cast into the. You can see there as well. So we see the same buildings, the same techniques. I'm very interested to understand whether this technique was actually transmitted across as it was then, the Islamic Caliphate, because they were both part of the same empire around about the time these buildings were built, or whether it was developed independently. And I think that's something we'll never really get to the bottom of, but it's very interesting to see that. And I'm now going to talk. Oh, there we go. I'll talk about the Great Wall of China. Again, relatively independent development, I think. But what we find there in the Western China plains, basically, is layers of tamarind leaf between each of the round earth lifts. Okay. Not very well understood, not very well researched, but essentially because it's researched by archaeologists who aren't really looking to engineer it and find out what's going on. But there's innovations going on there. There's no timber available, but there maybe is a tamarind plant that they can use leaves for. So we're putting stuff in to make the building stronger and better. Right, I'm going to finally on the historic things, because I've missed out a lot of things, but I just want to take some snapshots. I'm going to talk about formwork for round earth. Like I said, it's fairly round earth heavy as this, but that's my specific area of expertise. So here's a shot of how traditional round earth, you could argue, it was done in China, taken out of Joseph Needham's book that was published in 1971 but started in the 1930s. And so I presume this is taken from essentially before the Cultural Revolution and things like that. So this is a representation of the more traditional round earth in China. We can see a situation that some people who make round earth might recognise quite a lot, I'd say. Moving on, this is in Argentina. So this is taking people from Spain, or taking techniques from Spain and using them in Argentina. Again, what we'll notice from that is there's a lot of people on that picture. So I think, as we were talking about before, it's reasonably labour intensive. And you'll see that the techniques are very, very similar to what you would recognise now. I think we could give that picture to some people looking to build round earth outside, and they could probably work with that and use it. very similar picture, different part of the world. Srinagar, 1850 in North India. That's written in Farsi, which is Iranian, which was the language around that part of the world at that time. But a good, excellent description of all around Earth, all the techniques, how to do it, and what to do. But not very similar at all from the previous photos we've seen. And then this is the formwork that's until very recently used in Morocco. You'll notice they are almost identical, essentially. This is I think the formwork itself has been innovated and worked, but it's not really moved on very much from those traditional techniques. And I think that's fine. You know, we may well have reached the best way to do formwork like that. Is it now possible to take it further by more understanding? But I feel innovation, certainly in round earth formwork, hasn't really moved very far recently until we come up to the modern times. So I'm going to jump through into now. I wanted to not just say round earth, but we do have block machines. I like this picture. It's deliberate. There's a big bag that says cement there into it. So the people that are producing the block machines, you know, recommend cement. There's basically, are we able to improve this from this situation? I think we definitely are. What's happened in Western Australia? So this is the round earth industry in Western Australia. They started off. They used the soils they found in the 1970s. I think, as Graham was talking about, that's when these things really started to take off. Then they started to add a little bit of cement to the mix, and so in Western Australia, the buildings in the late 70s, the early 80s are clay soils and cement added to them, and then they hit on the idea of using limestone dust. And so a lot of the contractors in Western Australia now are using limestone quarry dust and cement, and calling that round earth is a long way away from some of the techniques we've used, but it's not that far away from that Spanish castle we looked at in terms of what's going into the mix. It's a product, it does what it does. I think to argue that it's green and sustainable and funky and things like that isn't necessarily right, but that's the material, essentially. And just jumping forward a little bit further in time, this is a watershed block that's been done out of David Easton's set of companies in California. Low cement, geopolymer. I think we're trying to address the cement in the block issue. It's extruded, it's made in a factory, essentially, but it is still block. And I've not really got a good answer of whether the holes in the block are filled with the same low cement polymer and whether that works. But as a block and as a system, it's getting there, and David Easton's doing a very good job of getting it out to market and producing shiny marketing images like that. Again, where we're at now, prefabrication, I think this is David Easton again. Off-site construction, reduces manual handling. There's all sorts of construction industry issues or arguments for prefabrication and division of labour, taking things, doing them once, doing them well, sending them out to site, making it easy, but it's definitely not the same as building your own house, and I think that's something that will come across a reasonable amount in this conference. And again, this is one example, but it's basically stealing stuff from other industries. This is a much better, lighter weight formwork. It's still been lifted up by a crane, but the formwork there isn't timber. We're using steel and aluminium, whaler beams and things like that. So it's perfectly okay to steal ideas and things from other industries and use them to our own ends, I would argue. I'd like to finish the now on this example I saw in Nepal, which is, to my mind, the pinnacle of earth plastering before we started the natural building ideas and revolution. So this was done in 1908, and we came across it. The building is a huge palace right in the centre of Kathmandu, very severely damaged by the earthquake. I think it'll probably get pulled down, in all honesty. But what you find there is the plasters that we have, they're 3 or 4 layers, 3 layers there, each with different amounts of each of the mixed designs into each of the different layers. There's an internal layer, there's an external plaster which has got different mixes, and there's clay, there's brick dust, there's rice husks, there's honey, and there's lime. Right? So each in different proportions for their position within the wall. And so I think you could argue this is the sort of thing that if we could figure out exactly what's going on with that, figure out why the honey is very good, for instance, does it react with something in the rice husk, does it do stuff, is it just a filler, don't know, but the people here were innovating and finding out the absolute best thing to do, and this may well be it. Right, I'm just going to jump through to the future. I don't know how I'm doing for time. I think I'm... Oh, perfect. Yeah. Okay, I'll talk for 4.5 more minutes and then no more questions. Okay, so we heard a lot last night about biomimicry, and swallows build nests like that. Everyone knows and everyone sees that. And we point it out. I really want to get a scanning electron microscope through that, understand, recreate that. I know from my research, it may well, you could argue it's just the added water into the mix in the swallow spit, I suppose, that's causing these little balls to be made and then stick together. Is there something else that they put in there? I couldn't tell you, really. And I don't think anyone's done a lot of research into it, but if there's some sort of New Zealand natural building research establishment going to be set up, then I think that would be wonderful. Everyone normally gives you the beautiful termite mound picture. That's the thing. That's the termite. What does the termite do? You know, what is in the termite's gut that produces and goes into the termite spit and produces that? I don't really want to milk termites, but you know, going forward, what's the termite doing? Can we find out? Can we steal it and start to use that sort of technology, really? Because nature's got it right. Nature's got it sorted. My feeling, and it's honestly no more than a feeling, is there is something going on with the starches in the straw. Either in the straw or in the rice husks, or the starches that are coming through the swallows or the termite. You know, something's happening, and I just think something is being added to the water that's giving us a little bit extra against what the water would normally give you. But I don't know what that is, and I'd love for someone to figure it out and tell me, please. Something slightly different. This is de Havilland Albatross, the last plane built with casing as a wood glue, so the structure of the aeroplane is timber. It's laminated timber, and the laminations were glued together with casing, which is a milk-derived product. That was then supplanted following or during the Second World War by an oil-derived product. There's an awful lot of casing kicking about. There's an awful lot of it in New Zealand. That gets exported. Is that an option? Is that something we can do? Can we put it into earth buildings? Will it work? Does it do stuff, essentially? And I don't know yet, essentially. And you know, going even more crazy. That's the. I'm not even going to try and say it. Coccolithus spores. How's that? That's the organism which secretes the limestone. Right? And so that's a very small scale, but is it possible to culture and grow these or something like that? We're talking, you know, we are essentially talking about coral, naturally growing coral. You know, can we force it? Do we want to force it? Do we need to do it? Can I grow a brick? Can I grow a house out of this? It's a bit crazy. It's probably not for next week, but is that the way forward? Is that the future? What have I got next? This is I don't know if anyone's seen this. This is Royal Rail stuff out of Stanford. Is it Stanford?
Berkeley.
sorry, some American university that's quite good. He's doing 3D printed clay. You can see that's a small scale. Is it possible to do a larger scale? Is this potentially where we're going? I'm not sure, but it's worth investigating and innovating, I would argue. And so my main thrust and argument and belief, I suppose, really, is we talk a lot about traditional building and natural building and sustainable building. I think that you could take all of those words away and just call it building. I do feel that we do need constant innovation. I'm not a big fan of cement. I do feel it's a blip in the construction industry international, timeline, should we say. We, as a human race, are clever. We've dealt with a lot of things. We took the greenhouse gases out, CFCs out of the atmosphere. We were able to do that. We've come up with other alternative solutions. I do feel we can come up with an alternative solution for cement. But I would like to take you back to this beautiful Jaquin mosque in Mali that I'm sure everyone's seen a picture of, and think that it's an amazing example of historic and traditional natural earth building. There's a picture of it 100 years ago, and it's been rebuilt since then. So yeah, I think keep innovating, keep building. Buildings don't last forever. Do stuff. Let's get working. So I don't really want to finish on that slide. So I'll finish on. There we go. Who's helped me? I've got a website. It's not very well populated at the moment. I currently work for LDE, and a lot of this work's been done at Bath and Durham universities, and a lot of it as a structural engineer was done at Integral Engineering in the UK. There we go. Let's finish on that. If you want to talk to Kiwis about anything today, talk to them about the flag debate. This was one of the flag options that wasn't put forward to the national vote. So thank you very much.